the key to this question, there's a few keys to this question. We're going to draw the force diagram first. Okay, guys, please. We're going to draw the force diagram of this first. The key is the second part, which says we have to keep it in equilibrium. Okay, what does equilibrium mean? Non-moving stationary, the net force is 0. Okay, so what's going to happen is basically I or whoever is pulling the sled is pulling against gravity. Okay, so let's get a few things in there. An 80-kilogram sled is resting on a frictionless hill angled at 12 degrees. So I'm going to draw my hill here, sort of like this, 12 degrees. I'm going to draw a box being my sled of 80 kilograms. And then I'm going to draw a handle like that at 30 degrees. Okay? That's what the picture is going to look like.
Is it okay if it's
Oh, sideways on the
Is it okay if there's an angle from the top to the bottom of the sled?
Yeah, it's fine.
It should be at the bottom.
I'm going to draw, I guess, for easy to see, right? All the vectors are parallel. Basically, what we're going to look for here, you're going to be finding what's going to eventually happen is this. There's going to be a force going down this way. You're going to have the balance force. You're going to balance it out that way, right? And the way you're going to balance it out that way is you're going to form another triangle like this. Okay, right? This is going to be the force applied is right there. You have to get this value here to match that value down there. That's all the rest of that. Okay. What are the other forces that are on that box? Sled, box, whatever it is. Go ahead. You certainly do. So this vector down here, I'm going to draw right down here is the right triangle. Okay, this is going to be force of gravity. Force of gravity is mg, which is 80 times 9.81. That's newtons per kilogram if you want units. What is 80 times 9.8? 720, 784. 784. Okay, the problem is this. We have to break that into components now. Okay, so what's going to happen is this vector is going to match, basically we're going to turn it into, let's try to redraw here. Are we okay with that? So this is going to be basically F down, we'll call this. And this is going to be F. This is my free body diagram doing right now. So the force down the hill that it's going is going to match the force up the hill that I'm attacking there. Okay. Where does that, how do I calculate what F down is going to be? Is that a question or answer?
So the force applied is going up and forward?
Yes.
So the up is not lifting the sled off the ground?
No. Okay, good question. Because what's going to happen, this is where, guys, please. Good question. So Michael's saying, well, this has got to be, there's a force up here too, right? Basically what's going to happen is, this is your normal force. Applied Y, we'll call this. The force applied, let's try this again here. F down, FGY, I'll just use FGY, FGX. I do that. Let's rephrase it. So this is going to be FGY, this is going to be FGX. This is going to be F applied X. This is the same as FGX. Okay. So the question is here, force FGY equals F applied Y plus force of normal. The magnitude, let's try again here, of all of this. Okay? If the force applied is bigger than gravity, and you guys have seen this, right? If you're pulling a sled and you just keep lifting it, it's going to eventually lift. Right? You're putting on more of a force upwards. Okay? Are we feeling somewhat okay with this? Is a difficult diagram. Okay, this is the most difficult diagram you've seen in this course so far, probably.
Are there two FGXs?
No, this is the same thing. This is equivalent.
Oh, that.
Good question. This comes from, sorry, good question. That and that are the same thing. Right? Those mean the same thing. Because that's the only force that's working down that way. Okay.
So what are
Okay, so the question is, what are we solving for? What are we solving for?
FGX.
Yes?
Versus
First.
Applied X.
Yeah, first, okay, ultimately we're solving for F applied, that's ultimately what we're solving for. Okay, in order to get that, you're exactly right, Graham. You have to find FGX, because FGX is going to equal F applied X, right? And then F applied X, again, you use that to find your F applied.
Do you need the F applied value?
No, not at all. In this case, it doesn't say. All right, if I would say to you, will the sled lift off the ground? Explain why or why not. Right, that would sort of be the, or I might say calculate the value of Fn, right? Because that would be, you know, the balancing to the thing, right? But all I'm saying for right now is how much force is applied to hold it at rest. That's all I'm saying, which is just the balance. Okay, how do I find FGX? The question was just F applied. This way up there. Way up there. All right. But it takes a long way to get there. I'll try and redraw my diagrams there, okay? So what's going to happen here is right, there's your F applied and FGX. Then what's going to happen is here we have on another right angle triangle beneath it. Here is FGX. Here is FG. And here is 12 degrees. So what this is basically this diagram, diagram there. This is this diagram there. Do someone follow? We almost come back from last year, I hope. For everyone else who didn't take this course last year. Okay. Basically it's the same. Michael, go ahead.
So, is the force of gravity X gonna equal the force applied X?
Good. So this, remember we said we need the force to cancel. Very good. So I should write that down. The magnitude of FGX equals the magnitude of F applied X. Yes, we told them all. Yes, we did. Because it's easier for me to see them looking like right triangles rather than on the plane. If you're on the paper, you can just rotate your paper very easily. And I probably could too, but I don't want to destroy this diagram. Normally I would if I needed a joke, but I'm not going to need a joke right now, so I'm not going to do that. Okay, how do you solve for anything here? What's the first thing I can solve for? I can only solve for one thing.
The values.
Yes, what do I have?
FG.
FG is 784. Okay, which probably helps us out. What's the only thing I can solve for right now? Robbie. FGX. How do you get FGX? You want to say sine law. We're not going to use sine law today. I'm not going to use sine law. I'm going to say that FGX equals 784 times sine 12 degrees. Technically, if you want to be mean with me, you can say, Mr. Sadler, if you divide that by sine 90, that is sine law. Sine 90 is actually equal to 1, okay, if you want to be mean, technically. Can someone please do 784 times sine 12? Oh, goodness. 163? 163 newtons. What direction would that be? What's the direction for that going to be? Parallel, you could say, I might even say down the ramp, I might say.
Oh, yeah,
Right? Okay, because FGX is heading down in this direction. I'm going to call that down the ramp. Because of that, we said that the magnitude of this is equal but in the opposite direction. So this is going to be 163 newtons up the ramp. Okay, so in order for that sled to stay still, you need 163 newtons in a horizontal direction in order to balance out. Austin, I'm picking on you because your hair is so magnificent. How do you solve for? Sorry, you can probably go home tonight.
So I think I was bringing that up kind of behind. I'm writing all this stuff down.
I got jokes to tell after. Nick, I'm picking on you then. Your hair's magnificent too. How do you solve for F? How do you solve for F applied here in the top triangle? Because the question where 163 came from, because we said, right, if it's 163 going down this way, it has to be 163 balancing that way. If they have to balance out. So Nick, how do you get F applied on the top there?
Usually use like sine of
saying on it backwards, it's gonna be cos, I think, though, right? That's what Jason? Yeah. Cos. So we're gonna say, cos of, I'll just do it slowly here. Cos of 30 equals 163 over FF. So FF equals 163 over cos 30. Sound good to you guys? Sounds right? Yeah,
Okay, going way back.
no problem? Yeah.
Why is f of gy equal to f of y plus f?
Okay, because gravity, the normal force is sort of just a leftover force. Somebody in physics want to explain this? Basically, normal force is like a balance force. It's just our normal force is a balance force. Like the reason I'm not going through the ground right now, there's a force, a normal force balancing up, pushing it. There's a normal force pushing. Oh, do you need to talk to me or we?
No, I'm just. Is anybody in here using a laptop?
Uh-oh.
There's a ding.
There's somebody having there's a few tablets and stuff. But.
Tablets? No, I'll deal with it. Okay, thank you.
Well, no, that's.
You have a laptop.
It's hiding, but I have.
Is it on? Is it on? Then he's not. I don't know, what is he looking
I'm
at?
feeling nervous now. I'm feeling really
Well,
good.
it's probably the iClass said that someone is probably using a proxy or a torrent in this area. Let's go.
Oh, Grant, you know.
Well, now when it happens to me, Noah, when I got.
Yes.
All right, enough with this. Let's just blame Mr. Sadler. Continue on here. Back to the question here, then, for the normal. Okay. Back to general here, guys. The general idea of a normal is if there's everything has to be in balance. I'm not moving right now. The force, guys, can I talk, please? The force of gravity is going to be pushing down. There's a normal pushing back up at me. The reason the normal is going to be less, the force of gravity equals if I try to lift my coffee cup and I'm putting, 100 newtons of force on this, it's still not leaving the ground. Okay, if I drag it like this, it's still not leaving the ground because gravity is balancing me. The force on the coffee thing from the table is going to be less. That's all that I'm saying. That's
Well,
the
once
normal.
the
But I
force.
don't know why you're adding this.
Well, because they have to be, because they're all up. They're added up because the normal force and the F applied are going up. That has to equal FGY going down. Like the top, they have to equal 0, right?
Okay.
These going up has to equal this going. They have to balance out there. Is that a structure and answer?
Yeah.
Okay. What is 163 over cos 30?
188.
188. 188.22.
Like,
Okay, therefore, you must pull 188.22 newtons on the handle. Okay, and that is a wicked cool question. Hint, hint, nudge, nudge. That actually matches 188.22. Is there a direction on that? Well, technically, what's the direction if I wanted to change that to a vector? Yeah, well, more than just up the hill though. 30 degrees plus up the hill. You know what I mean? Like up the hill, up plus 30 degrees. Yeah. Yeah. You could also say 42, I guess, as well too. 12 here, another 30, or 42. You could say.
It's always 30 degrees perpendicular.
I'm after this one. You might pull 188.22 degrees in there. Okay. Good. Time to do some proofs.
no.
Yeah.
I guess so, but
The proofs are going to be easy on the test. The proofs are going to be like the level of difficulty is on the assignment. The worksheet that I gave you. Oh, did I say no proofs? I misunderstood. Sorry. I did say I didn't. We didn't rephrase.
Are we gonna need
I
to-
meant stop. What I meant to say was when you said proofs, I thought, are you going to prove that u plus v equals v plus u? That's what I thought you meant. You won't have to prove that. No. Will there be like this piece of paper? Yes. Will there be stuff like on here? Yes, there will be. There'll be one or two that are the level of difficulty. Can I talk to you, please? There'll be one or two of these that are the level of difficulty on the assignment. So if you look at the assignment ones that are straightforward, yes.
Really wasn't to prove that if parallelogram prove that those marks.
Something like that. Yes.
Those never worked out if we were doing them.
Okay. We'll go through these. We'll go through some of these right now. Okay. But as far as the difficulty, I'm not going to destroy you on these. we're not gonna destroy you on the test or these sort of ones here. Okay, does that make sense, right? Like these ones, like I'm not here to touch your souls on these, okay?
Just the hardest.
Well, it'll just be like the ones on your, like the ones on your assignments, it'll be where the diagrams are given to you and things are, like hopefully those are nice. Okay, let's pick our favorite question. Let's stop this.
Work, prove that you.
No, no.